For the last couple of weeks, we've been going over the introduction to Couchbase Lite, talking about the products themselves, Couchbase Lite and Couchbase Sync Gateway. And then last week, we went into a deep dive on the architecture itself. Today, we'll be looking at developing with Couchbase Lite, specifically on iOS, with Jens Alfke. Jens has been heading the iOS part of the project for a while now, so he can give you an in-depth look as to how to actually develop and how that correlates with Couchbase Lite on iOS. So a quick recap from the last couple of weeks. We've been talking about Couchbase's mobile strategy, JSON Anywhere. We've been seeing an increasing push for NoSQL as data has become more rich, more unstructured, and we've been seeing a real push for that on both the web application side as well as the mobile application side. So today we have JSON in the cloud, JSON on the wire, and JSON on device. With JSON on the cloud, we have Couchbase Server, and that's connected to Couchbase Lite through Couchbase Sync Gateway. So today we'll be talking specifically about the Couchbase Lite piece. So without further ado, I'm going to hand it over to Jens. Jens?
Thanks, Jessica. So we can switch to my screen. All right, am I live? So, as Jessica said, I'm going to be talking about development with Couchbase Lite on iOS. To start out, I'll be showing you quickly how to install, where to download the pieces from, both Couchbase Lite and the demo app. And then I'll do a live demo of the sample app, which doesn't really do that much, but that makes it nice and simple and easy to explain. The main part is going to be a tour through the code, where I'm going to be showing some of the important snippets, some of the pieces of the app that actually talk to Couchbase Lite to do the various functions. And I'm going to use those as jumping off points for talking about the API calls that are used and the underlying model of the database and doing querying. And then finally, I'm going to go into a bit of stuff that's beyond what grocery sync demos, some of the more advanced features, just quick overviews of them. So first, okay, how do we get up and running? First, we're going to download Couchbase Lite. Then we're going to download the grocery sync sample application, which is just on GitHub. The next part, the assembly, is just to copy the Couchbase Lite framework into the sample apps folder so that Xcode can find it when it needs to link against it. And then we build and run. That's all there is to it. The first step here, you go to Couchbase's Couchbase Lite homepage at the URL at the top, find the download link for iOS, and once your browser finishes unzipping that, you'll have a folder just like over there with the Couchbase Lite framework in it. Next step is to get the grocery sync app from GitHub. Again, the URL is at the top of the screen. And if you're not too familiar with the GitHub UI, down on the middle of the right-hand side of the page, there's a section where you can either get the URL for a Git clone if you want to do that, or simply download a zip. And either way you do it, you're going to end up with a directory like shown on the right with the Xcode project, source code, resources, etc. And there's this frameworks folder there at the top left, which is where the framework is supposed to go. And I'll show that in the live demo. Finally, the last step to putting the pieces together is to insert tab A into slot B, go and drag the Couchbase Lite framework into that frameworks folder so that Xcode can find it. Now I'm going to do essentially the same thing live. So here I've got the two folders, just like they were downloaded. And take Couchbase Lite framework, option drag it in to copy it into the frameworks folder, double click the Xcode project to launch it. So here we've got the project, and then we simply run it. It's going to build and launch in the iOS simulator. So we've got here is a pretty simple application. It's just a very basic to-do list or grocery list app. You can just click to add an item. So we'll add, like, say, what DVD I've been meaning to watch. And it shows up in the list. We can click it to check it off, or click it again to uncheck it. Very simple. The interesting part of this is that we can configure it and give it the URL of a remote database to sync with. And got the URL here that I can copy, and then go over here and magically paste it in. So what's happening now, we see we've got a little progress bar here at the top, and it went away, so now it's done synchronizing. And the stuff that just showed up here is what's already in that database, which are mostly just random things that different people have added to it as they experiment with the app. And that's really all there is to the demo. Pretty much shown all the functionality here, except I can check off an item, click clean. So yes, you can actually remove items as well. So I'm going to spend the rest of the time going to the relevant bits of the code, just showing them here on screen outside of the Xcode context, so we can make them big and readable, and I can highlight pieces of them. First part, of course, is initialization. This is the stuff that will go into your usual application did finish launching method. The main thing we're doing here is grabbing this CBL manager object, which is the sort of central point or singleton, and telling it to create a database. So here's a little bit about the object model. A CBL manager, there's typically just going to be one of these. It's mostly used as a container for databases, named databases. So here we have a database called DB. There can be other databases as well, although a typical app is just going to use one. And databases are containers for documents. They're mostly just buckets containing documents with names, and you look them up by their names. So we've got a couple of documents here. And then a document, in turn, is a container for JSON. And I'm showing one here that's just got a couple of JSON properties. This happens to be the same schema that's used for the grocery sync application, but you can just stick anything into any document. It's similar to a property list, actually, if you're used to working with property lists on iOS or macOS, since JSON has most of the same properties as a property list, so you can be very free-form about what you put in. In here, I've also showed an example of an attachment. A document, in addition to the JSON properties, can have arbitrary size binary attachments added to it, which can be very useful because you don't have to base 64 encode them the way you do with JSON. So hypothetically, we could add like a little image thumbnail property to our grocery sync application with a picture of the item that you're supposed to get. So the database manager, as I said, is just a collection of named databases. It's usually a singleton. If you were just writing single-threaded code, you'll probably just use the shared instance to get it. If you want to run on multiple threads, you do need to create one of these for each thread that you want to run on. It is also in charge of actually finding the storage for the databases, which by default will live down in your app's application support directory. But if you wanted to customize that and store them somewhere else, you could use the database manager to configure that. Databases are primarily namespaces for documents. They also contain a couple of other things. They contain views, which we'll get into more later. They're not like UI views. They're like indexes in a SQL database used for searching and querying. It also contains validation functions, which are optional, which are a way that you can check the integrity of data before it gets added to the database. And finally, database is the kind of unit of replication in Couchbase Lite. Every replication takes a source and a target database and is responsible for transferring changes from the source to the target. So you typically specify which database to replicate from and to. Documents are, of course, where most of the action happens. A document has a unique ID within its database. Now, the ID can be an almost arbitrary string. I think empty strings might be forbidden, but apart from that, pretty much anything goes. They can contain almost arbitrary JSON. In this case, we reserve keys that start with underscores for our own metadata. You can put anything you want into any document. There's no schema. You don't have to work out the whole design ahead of time. Different documents can have different properties in them. You can come up with new properties later on in version 1.2 of your application, et cetera, et cetera. Denormalization is okay. This is a database term that means in a SQL database, you are encouraged to break everything down into the smallest possible pieces. And with a document database, it often works better to keep somewhat larger pieces of stuff around. So for instance, if you had a document that represented a checkers game, then instead of having every single piece in the game be a separate record the way you might in a relational database, you would just store an array of them into a single document that represented your state. And as I said, the documents can contain binary attachments of pretty much any size. Couchbase Lite doesn't impose any limit. It stores the documents in the file system, so they could be as huge as you can stand to download, really. And the most important piece, documents are versioned. We use a thing called multi-version concurrency control, which is quite similar to what a real version control system like Git or Subversion will use, where we track every revision with its own unique revision ID that's based on a digest of the contents. And we store a history of the revision IDs of the document over time. This turns out to be a really crucial thing to do for synchronization, especially in resolving conflicts. So back to our code. So hopefully the initialization here makes a little bit more sense now. First, we're grabbing the shared instance of the CBL manager, and then we're telling it to create a database with our constant for the database name. So if the database doesn't exist, the create database call will make it. We'll create a new one. If it already existed, it just returns the one that already exists. So it's pretty much exactly what you want when you're starting up your app. The next bit that we're going to do at initialization time is to create a view. And as I said before, this isn't a view like a UI view. This is more of an index in the database. For the main display, we're going to want to sort those to-do list items by date with the newest items at the top. So we're creating a view that's named by date. And we're creating this thing called a map block for it, which is a small callback function that's going to determine what goes into the index. And I'll be covering that in a little bit more detail in a moment. So back to the object model. The database, like I said, also contains views. Views are also named. You can have more than one of them as long as the names are unique within the database. A view has this thing called a map function associated with it. The map function is going to get called every time a document gets added or updated in the database. And its responsibility is to look at the document contents, which are that doc parameter, the JSON contents, and call emit. The emit function inside of a map will literally add an item to the index. The index has keys and values, and it's sorted by key. So the emit function tells it first what key to emit. Here's a picture of the index. And we're partway through indexing our grocery sync database. So the key here you can see is a date every time. It would actually be a full timestamp. And the value associated with it is that document's title, because that's what we passed in for the second parameter of the emit call. And the index also remembers which document each of these emitted key value pairs came from, which is useful if you want to get back to the document later on when you're querying it. So that index gets built sort of, you can think of it as at the time that the document gets updated. Then later on when we do a query, the CBL query class will go through and grab the relevant section of the index and pull it out and let us walk through it. So views use a map reduce mechanism. This is something that's used a lot in other NoSQL databases, especially CouchDB, which is where a lot of the inspiration for this design came from. Also various Google projects have used it. I think Google originally invented it. It's like an index in a relational database. It uses an application-defined map function. In your code, the map function is actually going to be a block, an Objective-C block. It's called every time a document gets added, and it gets to emit one or more arbitrary key value pairs into the index. There's also an optional map reduce function. That's the other side of MapReduce. The reduce function is not shown here. It's a little bit more advanced. It's used for things like aggregation, like computing averages or totals, and also for grouping, like to collect together all the documents that have particular subsets of keys. So in some databases, the map functions are stored as JavaScript code. For efficiency and to avoid having to bundle a JavaScript interpreter, we use native code for these instead. That actually makes them quite a bit faster. And it means you don't have to work in a second language. So back to creating the view. I've highlighted the bits here, important bits. So we're asking the database for a view named by date. And As with the database, this is going to create the view if it doesn't exist, or just return you the existing one if it does exist. And those 3 lines there that are highlighted are the contents of the map block. So first, we're going to grab the created at property out of the document. And if it has that date, then we're going to emit the date as the key, and the document itself is the value. That's just the rest of the JSON in the document. Now we actually want to create a query and hook that up to the table view. That's the main UI of the application. So we're going to use a CBL live query object here that we instantiate from that view that we set up above. We're going to set it to be descending order, and then we're going to connect our data source to it, which is an object in Couchbase Lite called a CBL UI table source, as you can see from the snippet of the header down in the box. That is a special class, a utility class that talks to a view and also talks to a UI table view, and will drive that table view's rows from the contents of the Couchbase Lite view. So queries have, if you're used to SQL, the feature set is a bit more basic or limited. You can ask for a range of keys out of an index. You can set up an offset and a limit if you want to do pagination. You can reverse the order, as we're doing in our view. And you can specify some more advanced things like grouping. The main limitation is that it doesn't have things like joins, and it can't do multiple different kinds of sorting. But you do have some interesting abilities like using compound keys or array-based keys that I'll touch on a little bit at the end. There is, as I said, this live query subclass, which is like a query except that it doesn't just hand you back the results and finish. It keeps running for as long as the object exists. And it will monitor changes to the database. So whenever there's a change to the database that updates the result of the view query, then it will send a notification to whoever's listening to it telling them the query is updated. And the iOS version this uses key value observing. So this is a part of what makes the UI update automatically in iOS. We really don't have to worry about keeping up to date because the live query is going to find out when stuff changed, like when new to-dos got added or deleted, or when stuff got pushed in from replication. And it tells the table view to redraw itself. Queries also have some additional goodies that are coming up in a future beta release. We've got full text indexing if you've got some properties in your documents that have large amounts of text, like product descriptions. And also geoqueries for testing basically whether XY coordinates fall inside a bounding box, which is extremely useful if you're doing any kind of map-based queries, like points of reference near the current location, say. These aren't available in the beta that's out yet, but they're going to be in an upcoming beta and in the GA release. So let's continue on with our saga of this view and the index. So here's the index, or part of it, that got built before at indexing time. And now we're querying, so we've got the CBL query that's grabbing out the rows from the index. The CBL live query addition to CBL query is going to keep on updating that whenever things change, passes that to the CBL UI table source object, which acts as the UI table view data source, and then updates the table view. Back to the example, so there's the CBL live query on the first line that we've created, and then second highlighted bit where we're actually plugging that query into the data source. We also set a property on the data source called label property, which is a convenience where a lot of the time you've got some JSON property in your document that you want to show up as the main text label in your table row. So if you just set this label property on the data source, it knows to grab that property out of your document and stick that into the table view. So now we'll take a look at the nib. This is how things are wired up. The file's owner, which on the top left, which is the controller class, has an outlet pointing to that Couchbase Lite table source object that we talked about. The table source, in turn, has a outlet pointing to the table view that it's supposed to be driving. And then the table view points to the table source as its data source outlet and points to the controller as its delegate outlet so that the controller can have some influence over the view as well. So now how do we display the table cells? There is a slightly different method that we implement from the usual one. There's the usual UI table source, we'll use cell. This is one that's provided by the CBL UI table source. And the difference here is that, as in the highlighted row, it's instead of just passing you an index, a number for the row, you're actually getting the result row out of the query. So the CBL query row object is sort of like the cursor in a database. It contains the properties for the current row. And in the code down here, the main thing we're doing with that thing is we're grabbing the value out of it. And if you think back to that map function, the map block, the value is that second parameter to emit. So every time we emit a key value pair, where the key is the date and the value is the document contents, this is the value. So we get that as a dictionary, so then we can grab the check property out of it, which is going to be an NS number with a Boolean telling us whether that item in the to-do list is checked off or not. And then we grab its bool value and then use that as a conditional to update the display of the row, highlighting the color of the text and also putting in that check mark icon. Next thing is to actually update the item when the user taps it. And the tap will trigger the standard table view did select row at index path callback from the table view. So in that, we're going to grab the row from the index path and then ask the data source for the query row at that index. So the data source is, of course, keeping track of what is supposed to be shown for all of the rows. So it can tell us, oh, this row at the table view has this query row added. Once we've got that, we can get its document. We create a mutable copy of the document properties. So now we have a mutable dictionary that contains that document's properties. Since it's mutable, we can now update that check property with the inverse of what its old value was. So if it was true, it gets set to false. If it was false, it gets set to true. And we store that back into the mutable document, the mutable dictionary. The last step, now that we have the new document contents, is we call put properties back onto the document and store the new value into it. To add a new item, we're going to implement the standard text field end editing. So after the user's typed some stuff into the text field at the top and then pressed the return, this thing that's called, first it just grabs the text out of the text field, clears the text field. Now we create a new dictionary from scratch. So we make a dictionary using the new Objective-C dictionary syntax. We set up the text property, the check property initialized to no because it's not checked yet. And for created at, this is going to be a date. Only, unlike property lists, you can't store NSDate objects in JSON. So we're using a utility class called CBL JSON that has a convenience method that converts an NSDate into a string that encodes that same date in the standard JSON date format. Now that we have the document as a dictionary, we save it pretty much exactly the same way. We grab a document. In this case, we want a new document, and we don't really care what its ID is, so we just ask the database for an untitled document. So we just get some random new document that doesn't exist yet. Then we put the properties into it and save them. Note that we don't have to do anything here to redraw the table view, because as soon as the document goes into the database, that live query is going to trigger, rerun the query, which now contains our new document up as the first item because it's the newest, and then redraw the table view for us. So really a good design process in writing apps using Couchbase Lite is to do everything data-driven. So anytime a change happens in your database, your UI will get notified and update. The opposite process here is deleting items. There was that cleanup button in the UI that offers to delete all the checked items for you. And here's how it's implemented. First, we create a property called checked documents. And since our amount of data that we're expecting to have, and this is pretty small, like maybe a few dozen or 100 at most items, we're just going to go and iterate through all the rows from the data source. And for every row, we grab its document, we look at its checked property. If it's checked, we add it to the array. And then finally, we return the array of all of the checked documents. Then we use that property in a method called delete checked documents, which is going to get called in response to that button being tapped. So we just get the self.check documents, and then we pass that to a method on the data source called delete documents. And you might be asking, well, why are we telling our data source object, which is mostly responsible for driving the table view, to delete the documents? Why don't we tell the database directly? And you could tell the database directly, and it would work, but the data source knows to tell the table view that we're about to delete those rows so that the table view can do its nifty little deleting rows animation. If we didn't tell the table view, we wouldn't get the animation. It would just kind of flash with those rows gone. So we use the data source's intermediary method delete documents, which will first trigger the animation and then pass the deletion on to the database. Okay, so at this point, what we've got here is a fairly complete little single user to-do app, which is completely uninteresting because there's about 1,000 of those in the App Store already. The cool part that you came here for was sync. And this kind of shows part of the way that app development works with Couchbase Lite, which is that you can build your app kind of ignoring the networking part in the beginning and just write it as a single user app that uses a database. And then after that, you can pretty much glue in the sync. And for the most part, it just works. So here's how we do it. Some more startup code here. We're going to set up some replications that are going to run in the background and actually synchronize stuff. So we're going to ask the database to replicate with a URL. So we've already got a remote URL, which in this case was configured through the UI. In a lot of apps, it would just be a hard-coded constant because you already know ahead of time where your server is that you want to sync with. The replicate with URL method is returning us an array. It returns us 2 replications. Since replications are one-directional, you get both a push and a pull. So we pull the pull and push out of that array. We set them both into continuous mode, which means that we want those replications to keep running even after they're finished, because we want them to sit around in the background and watch for changes either locally or on the server and keep replicating those. And then we set up some notifications with the notification center. And we want to observe this database change notification on both of those replications. Sorry, replication change notification. This is so that we can get notified as the progress of the replication changes. And I'll show that in a bit. So back to our object diagram. The database contains replications. And as I said, you mostly create them in pairs, although it's not required strictly. Each replication has a direction. It knows whether it's pushing or pulling, where push will send stuff from your local database to the remote server. Pull is the opposite. It grabs changes from the remote server and puts them into your database. Each one knows the URL of the remote database, and it can also have other properties like authentication tokens if you are logging into the remote DB using Facebook or OAuth or something like that. And then the lower arrows show how the replications will post notifications that can drive your UI and show progress to the user. So each replication is one-directional, as I said. There's 3 different possibilities. They can be one-shot, continuous, or persistent. The one-shot replication just runs, finds all the stuff that needs to get copied at that moment, copies it, and then stops. Continuous does that, but then it keeps on monitoring changes. It'll keep on running until the application quits or until you stop it explicitly. And a persistent replication will actually keep going beyond your app quitting. Its state is stored in actually in a secret background database. So the next time your app launches, your persistent replications will just wake up and keep going again from where they left off. This is pretty convenient because then you only have to configure the replication either the first time you set up the app or if the state of it ever changes. The replicator, the thing that's actually doing the replication for you, runs in a background thread, and it's almost entirely isolated from what you're doing. It takes care of pretty much everything that needs to be done to do the nasty work of operating on a mobile connection. So it can tell when your device goes online or offline. It'll immediately begin re-replicating when it comes back online, looking for any changes. It can deal with connection errors, decides whether they're transient or permanent, It'll retry after a while if it got errors. So it kind of does all the best practices for getting stuff over the network or sending stuff over the network. The only part really that you see of it are the notifications that it sends you with, when it makes progress or when it gets errors. And those notifications, you can get them either through key value observing or NS notification, depending on how granular you want to get. Often NS notification is the best way to go, the easiest way to go. And here's how it works. So here we have, it's a NS notification observer method. It's, if the, NS notification center there should be just NS notification, typo. First, it's going to check whether either the pull or the push replication is in active mode, which means that it's actually transferring stuff. If it is, we want to figure out how far along they are. So we're going to add up the completed properties of both the pull and the push replications. The completed property tells it how many documents have been completed so far. That is, how many documents have been successfully pushed or pulled in this session. Then we add up the total properties, which represent their current estimate of how many documents there are that need to be transferred in all. And obviously, simple division of these two will give us a progress amount between 0 and 1 that we can then use to stick into a UI progress indicator to present that bar graph that was briefly up at the top of the screen. If the replications aren't active, the code then just switches to showing the sync button. So we hide the progress bar, and there's actually a button up there that lets you configure the replication. Your UI, of course, will probably be different. And the last part of it looks to see whether either of these replications has an error. And if it does have an error, then we're going to pop that up in an alert. In a real app, you probably wouldn't want to make a modal alert pop up as soon as there's an error. You might want to display it more unobtrusively to the user. That pretty much covers what grocery sync does. And we encourage you to look through the rest of the code and look at the parts of it that just make it a regular iOS app and how everything fits together. It's also a really good app for, since it has so few features and everybody knows about to-do lists, you can probably think of a dozen features to add to it and go ahead and do them. It's much easier to add stuff to an app that already works than to try to learn a new technology by writing an app from scratch. So let's look at a couple of things that go beyond what Grocery Sync can do. The biggest one, kind of the most exciting one that you'll definitely want to use in writing your own apps is models. If you've used Core Data at all, then you're familiar with NS Managed Object, which is a very useful class that you can make your object model inherit from. And the main benefit of it is that you can interface with it more like an Objective-C object and less like an arbitrary dictionary of stuff. So here we've got a really simple object model for some extension of Grocery Sync where you can have multiple to-do lists. So we now have a list, and a list owns multiple tasks. And we can define our own Objective-C classes for these. So we have a task class that inherits from CBL Model, and we just give it some native properties using the regular Objective-C property syntax. It's got a title, a created date, checked off. It's the same schema that we're already using, but notice that in this case, we can directly declare the created date as a date instead of having to jump through converting it into JSON. And we can directly declare checked as a Boolean instead of having to grab it out of the value of an NS number. We also have a list property that's going to identify which list this task belongs to. And list is our other model class, so we can just make a direct pointer to that class. Over on the other side, we have our list class, also inherits from CBL Model. And it's got a title as well, and then has an array of all the tasks that it contains. Behind the scenes, of course, what actually makes this useful is that each of these things is referring to a document. There's a one-to-one mapping here between the documents and the model objects, but you really hardly ever have to deal with those documents. The model objects will grab the document as necessary. They'll load it from the database when you access the properties. If you change the properties, they're going to buffer up those changes just locally until you tell the model to save, and then save it back to the document. So as I said, the model is kind of like NS Managed Object. A handy way to think about it if you're used to Core Data. It's not quite as fancy as NS Managed Object and the rest of Core Data. primarily that we don't have a lot of the fancy integration with queries. The coolest thing that CBL Model does is that it kind of gets you out of having to take apart dictionaries full of parsed JSON and just directly work with native properties. You can use any scalar type, integers, booleans, floats. You can use NS strings, of course. You can use NS dates. They get mapped into those date strings automatically for you. You can stick NS data objects in there. Again, property lists support NS data, but JSON doesn't. So if you do store data in JSON, you have to base 64 encode it. Model just takes care of that for you. If you stick data in there, it'll just convert it into base 64 for you. But that said, if you want to put large amounts of data in, you're much better off using an attachment. You can also have a property that's a reference to another model document. This gets encoded as a string containing the document ID of the other model's document. And you can have arrays of these. So if you want to have a whole array of numbers as part of the document, you can just create a property that's an NS array and put in a little annotation in your implementation that says that the items in the array are numbers. All these properties are key value observable. So if you've been already, if you're already used to designing object models and having your controllers and your views be driven by changes to the model, which is the best way to design an app, then everything like that will still work in this approach. This is also really nice because that means that as the database changes, so if one of your documents gets updated by a sync coming in from a remote server, then the model's properties will update since the document is updated. The model is going to send out notifications, and your views are going to be observing those notifications and will just update automatically. A more subtle benefit of models is that they give you mutable state. Documents are only kind of semi-mutable. You have to change them in batch. If you think back to the examples I gave of updating the check mark, we first had to load that dictionary in, make a mutable copy of it, and then store the whole dictionary back into the document. It's often a lot more convenient to just change properties one at a time and then save them back when you're done, like when the user hits OK or wants to commit something. And CBL Model gives you that abstraction on top. The changes that you make to the properties just remain in RAM until you call save on the model, which will actually write it back to the document. As I said, we don't have query-based relation support. That's kind of the biggest missing piece. So in the case of the multi-to-do list, there really ought to be a simple way to just, from that to-do list, get a property on it that's an array of all of its tasks. But we don't have direct support for that yet. Instead, you need to use a query. So if the database is just a bucket of documents, just a bucket of JSON, then there are no tables. And if you want to have different types of documents, like the to-do lists and tasks, how do you tell them apart? There's a simple convention of using a type property in your JSON. And you just give it a different string value, or you just make up different strings for different types of documents. So the map function, as shown here, can just check that the document is of the right type and then emit the value that it wants. So this map function would be only emitting data into the index for the to-do items, not for the lists, because first it checks to see that the type is an item. So let's look at how we would do some of this stuff. So here is part of our method that draws or updates the table cell. And all we need to do now is, once we've got this query row, we just get the row's document and then create a task model for that document. And then from the task, we can just access its properties directly. The text property and the checked property is just a native Boolean, so we can use it directly in the if. It really simplifies the code. Let's look at how we do querying. It's getting a little bit more advanced. So I said that we didn't have direct support in the model for getting the list of tasks associated with a particular to-do list. So here's how we do it. First, we need to think about what happens at indexing time, so when the documents get created or updated. The map block is going to be a little bit more complicated now. So first, we only want to check if this is a task document, not a list. So we compare the document's type. If it is, we're going to grab a created app property, also its list ID property, which tells it which list it's part of. And the key that we're emitting into the index now is an array. It's a tuple of first the list ID and then the date, as you can see down in the lower right corner in the table there, showing the index items. What happens with this is that the index will sort these pretty much the way that you expect. It's going to sort them by the first item in the array and then the second item. So all the items in list 1 will sort before all the items in list 2, which will sort before all the items in list 3. And since the second item is the date, the sort of the secondary sort order that we have here is by date. So we now have an index where sort of all the items for one to-do list are grouped together, and within that grouping we're ordered by date. So now all we need to do on the query side is to get the range of items in the index corresponding to the list that we want. And we do this by using two new properties in the query, which are the start key and the end key. Now, this part looks a little bit weird, so bear with me. They're in what seems to be reverse order because we told the query to be descending. So since it's walking through the index in descending order, the start key is going to be the first one that it finds, and the end key is going to be the last one that it finds. So start will be the highest ordered one, and end will be the lowest ordered one. The start key that the start key that we want is the highest one. So we want pretty much like the item with my list ID and the highest possible date. And we use an empty dictionary here to represent the highest possible value within an array, because an empty dictionary happens to sort higher than any string or any other object. For the end key, we want to stop indexing when we get back to the first item in that. So for that, we can just use a single element array, because that will sort before anything else that has a second element in it at all. So what we've really set up here is a query range for all of the items in the index whose first item is the list ID that we're looking for. And the little graphic down there shows that we're bracketing out just the items for list 2, if that's the list that we were told to get. Okay, so that's quite a bit that we've covered. I've got some URLs down at the bottom, again, for where to download the stuff from, and also a link to the API documentation, which is very handy to look at when you start writing any of your own code. Our next webinar is coming up in a week, next Tuesday, same time, 10 a.m. And Trond Leiden's going to be talking about developing with Android. So it's going to be pretty much the same topics as this talk, only specific to developing in Android. So if you're doing cross-platform apps, you definitely won't want to miss that. Back to you, Jessica.
Thank you.
Thank you, Jens. We have a few questions coming in, so can jump on them. And as Jens said, next Tuesday we have this webinar on developing with Couchbase Lite Android. You can register for it at couchbase.com/webinars. So the question from Mel, is there, you mentioned that I think during the presentation, but it's good to reiterate, is there any limitation to the size of the document that I'm syncing? Do you have the ability to chunk large objects? For example, a follow streaming app could have large follows that I want to sync.
So Couchbase Lite itself doesn't really have any limits on size, although JSON isn't really that well suited to huge amounts of data because it all has to get parsed and then converted from objects back into JSON. So if you're going to have really large stuff, you should be storing it as an attachment. And attachments are just binary blobs. Each one of them gets stored as a file in the file system, so there's really no limit at all. You could have gigabyte-sized attachments if you had the room and you could stand waiting to download them. On the server side, the Sync Gateway currently has some smaller limitations on things. There's currently a 10 megabyte limit on the size of the JSON data, and I believe also a 10 megabyte limit on the size of an attachment, which we realize is for attachments kind of problematic. So we're working in a future beta, we're going to be relaxing that and storing them externally so they can be arbitrary size.
Perfect, thank you, Jens. This is, again, I want to remind everyone, last chance to write your question if you have any, using the chat box on GoToWebinar. So another question is, what version of iOS are required for Couchbase Lite?
We are requiring iOS 6 or later.
Okay, thank you. And another question from Doug. Any plans for use with desktop application, either Couchbase Lite or an embedded Couchbase server?
I can take that one. That is something that we are looking to do today. And in fact, for Couchbase Lite for iOS, for the Mac, if you're looking to be able to build for the Mac OS target, you can do that today using the GitHub project. But we don't have any binary bundles for it available yet. But it is something that we are thinking about.
Right. Since as Jessica said, we also support Mac builds. If you check out the project from GitHub, then you can just select the Mac target and build that. The code is almost identical with a couple of if-defs, just simply because iOS and Mac OS are so similar under the hood at below the GUI layer.
Great, thank you. Another question is, can we do peer-to-peer sync between two iOS devices without going through the server?
You can. You're sort of forging a bit into unexplored territory when you do it, but the APIs allow it. What you do then is you would use Bonjour to advertise that you are available for syncing, and you'd use an optional component called the Couchbase Lite Listener, which adds a simple HTTP server that supports the same REST API that's used for syncing. So it makes Couchbase Lite able to support the other side of a replication. So once you've done that, then another Couchbase Lite instance can use Bonjour to look you up. And from there, you just construct a URL that has the IP address and port number of the other device and tell your Couchbase Lite to sync with it. There's a couple more details than that, but it basically works. The replication protocol was designed to be multi-master, so it doesn't just assume that there's one central server that everybody syncs to. You can set up arbitrary topologies with different nodes syncing with each other. And even if they're syncing both to each other and then later with the server, things won't get confused. The data effectively remembers what the history is going from one place to another, and so conflicts get combined together in the right way.
Thank you, Jens. Another question that we have is, what thread should I start CBL Manager on? The main thread or a background thread?
It kind of depends on the requirements of your app. So the heavy lifting, the replication work in particular, and a lot of the querying get done on a background thread. So they're not going to interrupt your UI. But document lookups are done synchronously to simplify the API. So in some cases, you might find, like if you've got really large documents or you're grabbing a bunch of documents at once, that it's introducing more latency than you want for your animations. So you can start the whole thing. You can instantiate the CBL Manager on a background thread. The caveat there is that Couchbase Lite objects should be used on the thread that they were created on. So if you do that, then you're pretty much committing to doing all the Couchbase Lite access on that background thread. So you can use GCD techniques to send blocks between your threads so that you can be running your UI on its thread and then telling the background thread to do the operations on the objects.
Perfect. So another question that we have is, how do I do a Twitter-like infinite scroll?
That's a good question. You will want to do that using pagination. So even if you have the last 10,000 tweets in your database, which is perfectly feasible, you probably don't want to grab them all out at a time because you might run out of memory and the query might take too long. What you can do then is the same kind of technique that you'd use when working with a relational database, that you would set up an offset and a limit in your queries, or actually a start key and a limit. So initially the view is scrolled to the top, so you might just say we're just going to set a limit of 100 and just get the first 100 tweets. If the user scrolls past that, then we realize that we've gone past the end and we run a new query starting from the same key that was the last tweet that we got before, and again with a limit of 100 to get the next 100 tweets from there, and so on. So you only need to keep in memory the ones that you're using. This would be a really cool feature to add to that table controller utility that we have. And we might do it someday, but for now it's something that you can build on your own.
Great, thank you. Question from David. Do attachments replicate from CouchDB to Couchbase Lite, and are there any limitations here?
Yeah, the whole replication protocol is compatible with CouchDB. So any databases you have in CouchDB will replicate fine to Couchbase Lite and vice versa. Attachments work fine. Yeah, CouchDB also doesn't really have any limitations on size of attachments, so you should be fine with any amount of stuff that you want to transfer between them.
Okay, and a question from Mark. Can replication run if the app is closed by the user?
Yeah, so if, ordinarily when your app goes into the background, when the user hits the home button, your app can apply for some extra time to finish stuff. And if you do that, the Couchbase Lite will recognize that, and it will finish up its replications and stop. So that kind of lets you finish transferring some stuff. There are some new backgrounding modes in iOS 7 that we don't have explicit support for, but should be pretty straightforward to add into your application. So for instance, your app can get a kind of silent push notification from your server, and it will wake up in the background, but invisibly to the user. This is a general technique that can be used to tell applications to go and update data in the background. If you have your replication set up as persistent, then everything will just work, because when the push notification tells your app to wake up, then Couchbase Lite will wake up those replications. They will go and grab the new data from the server. There's another type where you can register for periodic time in the background. You could say, like, every hour I want to wake up for a little while. That's the one that I think is going to take a little bit of code for you to set up, because you need to hook up in your application delegate to make that happen. So you probably need to have your application delegate get called, that it's time to run your background task, and then you'd need to set up a replication, let it run, and then stop it when you run out of time.
Thank you. We have another question from David. Does Couchbase Lite support document ID namespacing like CouchDB with IDs like book/book_name? Are there any limitations to IDs in Couchbase Lite that don't exist with CouchDB?
I believe the naming scheme is pretty much identical, because otherwise there'd be compatibility issues during replication if you had documents that couldn't be represented on the other side. I don't remember offhand what the exact limits on names are. You can have a slash in a document name. It doesn't really mean anything magic to either CouchDB or Couchbase Lite. I'd have to look at the source code to figure out whether there actually are illegal characters. But as far as I recall, there really aren't. So yeah, slashes in the name are fine as long as you realize that they don't have any particular meaning to the database. They're just conveniences for you to use in assembling IDs.
Thank you, Jens. A question from Paul. How do I show a spinning while the data is loading in a table?
I'm not sure whether this means like during replication or if it's actually taking a while for your table view to load, then you might, I think showing progress during that is probably beyond what the regular, that regular table view controller class we have will do. But that class is just a convenience. It's not doing anything magic. It's just common functionality that we're bundling up. So if you wanted to, you could take the source code for it, make your own copy of the class, and put that functionality in, or even just write it yourself from scratch. It should be pretty simple. Doing a spinny during replication, if that's what you meant, is really just kind of, it's the same code that I showed in the walkthrough, that you would just notice the state of the replications changing. And when any of your replications went into the active state, then you would turn on that spinny progress indicator. And otherwise, you would turn it off.
Thank you. So another question is, how do Couchbase Lite databases map to buckets on the server, or are Couchbase Lite databases the same as channels?
So this is more of a sync gateway question, and I probably shouldn't get into detail on it because we're almost out of time and it's a little bit off topic for this. Hopefully we'll have more of a deep dive into the sync gateway in a future webinar. Databases do correspond to buckets in the sync gateway. And the channels are really tags applied to subsets of documents so that you don't have to sync the entire remote bucket.
Great. And one last question about the availability. So right now, Couchbase Lite is in beta. Do you know when it's going to be available for GA?
Sounds like a product manager question.
Sure, I can take that. Yeah, so we're scheduled for GA late January, early February, so look forward to our GA then.
Perfect. Thank you, Jessica, and thank you, Jens. I think that's all we have for today. I hope you found the presentation useful. And again, I want to remind one last time that next Tuesday at 10 a.m. Pacific, we will have Developing with Couchbase Lite Android. So again, thank you both for the presentation. Thank you. Yeah.
I know that people are going to want to look at the slides up on SlideShare or something like that. Can you?
Yes, and tomorrow we will send, as I said at the beginning, a follow-up email with the link to video and slides since this session has been recorded. Again, thank you everyone for attending today, and I hope to see you next Tuesday.